In this video, I'm going to show you the correspondence between multiple regression and Pearson correlation, or more appropriately, multiple correlation and Pearson correlation, because the association between predicted values in a multiple regression and actual values is the same thing as multiple R. So let me just show you with this example based on education and IQ as predictors of earnings. So if I were to run a multiple regression, I'd go into Analyze, Regression Linear, and then I would put earnings as the dependent variable, and then education and IQ in the independent variables box, and then just click OK. And this gives me the regression equation in the last table. So I've got the intercept of 56,261. Let me just push this out to 3 decimal places because I'll need that to do the calculations. And move that out like that. So now we've got 3 decimal places, negative 56,261. And then we've got the unstandardized beta weights associated with education IQ. So if I build a regression equation on the basis of these values, I can predict each person's scores in my data file. So let me do that. Transform, compute, and I'm going to call it predicted values. And then I'm going to correlate the predicted values of earnings with actual earnings. And I'm going to show you that Pearson correlation between predicted values and actual values is multiple R that was estimated in the multiple regression. So I'm going to start with the intercept, which was 56,000. Let me just move this around. So negative 56,261.421. So I'm just entering this intercept plus the multiplication of education, everyone's education score, times 3756.289 plus IQ, everyone's IQ score, times 501.978. So I'm just building the regression equation in SPSS in order to predict each person's scores on the basis of the intercept and the 2 unstandardized slopes, each of which is multiplied by the corresponding variable. So I click on OK, and that produced a variable in SPSS, predicted values. Now I'll show you there's an even easier way to get this. You can go into Analyze, Regression Linear, and then click Save, and you want predicted values. Let's say unstandardized. Click Continue, click OK, and SPSS has created a variable called pre_1, and that's where I got these predicted values. So I did it the long way to show you how to use the regression equation, and here's SPSS doing it quickly. Now, getting back to the point of where does correlation fit into multiple regression? Well, as you know, the multiple R associated with this multiple regression analysis is 0.361. I showed that in the foundation section of the chapter. And that corresponds to an R square of 0.130, or 13% of the variance was accounted for in the model. This multiple R is simply the association between the predicted values and the actual values of earnings. So let me show you. Analyze, correlate, bivariate, predicted values, well, let's take the ones that I actually created, predicted earnings and actual earnings. And the correlation comes out to 0.361, which is just like the multiple R, 0.361. So there's nothing really mysterious about multiple R. It's really just a correlation between the predicted values on the basis of the regression equation and the actual values. Now, a benefit of calculating the predicted values is an understanding that it represents an association, and specifically the multiple R, is that you could create a scatter plot, a multiple regression scatter plot, on the basis of your predicted values and the actual values. I'll do that in a separate video.